Algebra 2, 3-1, solving systems of equations. So hopefully you remember this a little bit from Algebra 1. Here's what a system of equations is. This is two or more equations with the same variables. And we graph them on the same coordinate plane. So, two or more equations with the same variables on the same coordinate plane. One other definition we want to talk about is solve a system. When we're asked to solve a system, we are trying to find where the lines meet. We solve a system by finding where the lines meet. Now, when we do this, we're going to find an ordered pair. Or a point. When two lines cross each other, like so, they meet at one point, and this point has an x value and a y value. So we need to we need to find an ordered pair when we solve a system of equations. Now we'll see a little bit later that there's also a system of equations that might be parallel or might be two lines on top of each other. We're going to look at that in a little bit. First, all of the ones that we're going to look at are just two lines that cross each other at one point. And so this ordered pair satisfies all equations. Meaning I can put those x and y values into each of the equations and the equal sign will still be true. Everything will still be, that the x and y values will work in each equation. Okay, solve by substitution. Let's get right into some examples. So we're going to look at two different ways of solving systems of equations in this lesson. And the first one is solved by substitution. So I've got 5x minus, not plus, sorry. 5x minus 3y equals 23. And I've got 2x plus y equals 7. So I'm going to solve by substitution. Notice how I've got this y all by itself. It's not 3y or 4y or whatever, it's just y. So notice how my variable is all alone. So solve for it. When you're using substitution, it's the easiest if you have a variable that's all alone. So let's solve for this variable here. I'm going to subtract 2x from each side, so I get y equals negative 2x plus 7. Now I take this y equals to negative 2x plus 7 and I plug it into this original equation. So if I've got 5x minus 3y, I'm going to put the 2x plus 7 in there equals 23. So I've taken this, what y equals, and I've substituted it in for y. That's why it's called substitution. Now I just solve for x. 5x minus negative 3 times negative 2x is going to get me a positive 6x. Negative 3 times positive 7, negative 21 equals 23. I'm going to combine these like terms, so I got 11x, and I'm going to add 21 to both sides. 11x equals 44. Divide by 11, both sides, x equals 4. Now, I'm not quite done yet, because remember, I need a point. I need an ordered pair. So for this one here, I know that 4 is going to be my x value. Now I need to know what my y value is. Now all I need to do is take this x equals 4 and plug it into one of these equations, or I could plug it into this one. So I'm going to plug it into this one. Y equals negative 2 times 4 plus 7. I've got negative 8 here. Y equals negative 8 plus 7. So that gives me y equals negative 1. Negative 8 and 7 is negative 1. So here is the point at which these two lines cross each other for negative 1. If I were to graph these, they would look something like this, whatever, and there would be a point right there where they cross, and that is for negative 1, that point where they cross. Let's do another one. Now this would be a we try, but it should be like a you try. Let's see how you guys can do here. What I'm going to do is I'm going to say, hey, if you feel comfortable, pause this. Here's your equations. X minus 7y equals 11. 5x plus 4y equals negative 23. If you want to give this a go, do this as a you try. If not, just follow along after I tell everyone else to pause. So if you want to try this, pause it, get to work. Now let's go ahead and see how you did. Let's go ahead. All right, so we're going to use substitution again. And notice here I have this x by itself. So I'm going to add 7y to both sides to solve for x. So I've got x equals 7y plus 11. So that's just the same equation. I've just rewritten it that way. And so now I take this 7y equals 11, which is what x equals, plug it in here for x. So I've got 5 times 7y plus 11 plus 4y equals negative 23. So I've just taken this equation, rewritten it here with this x value, which is 7y plus 11. Distribute this 35y plus 55 plus 4y equals negative 23. Combine like terms here, so I've got 39y equals, I'm going to subtract 55 from both sides. 39y equals 78, negative 78. Divide by 39. And y equals negative 2. All right, I'm not done. I've got my y value, so I'm going to put my answer right here. My y value is negative 2. I need my x value now, so I take this negative 2, I'm going to plug it into this one again. X equals 7 times negative 2 plus 11. 7 times negative 2 is negative 14 plus 11, which equals negative 3. So I have negative 3, negative 2 is the point where these two lines cross. All right, last one. This one is a you try. Do this one by yourself. Negative 6x minus y equals 27. 3x plus 8y equals 9. Now before you do this, notice how I've got a negative y. So when I get this negative 6x out of here, I've also got to multiply both sides by -1 to make this y positive. You need the y to be positive over there by itself on one side of the equal sign. All right, so pay attention to this negative sign. Go ahead and pause and try this one out on your own. Go. All right, let's check it out, see how you did. So I'm going to solve for y here, because that's what I want to substitute. And so I'm going to add 6x to both sides. I've got negative y equals positive 6x plus 27, because I added 6x to both sides. Now I need to multiply everything by -1. So I get y equals negative 6x minus 27. And so now I'm ready to take this and plug it in for my y value in the other equation. So I've got 3x plus 8 times negative 6x minus 27. Where am I? Equals 9. Okay. So now I've got to distribute this 8x. I've got 3x plus, but it's going to end up being minus, right? 8 times negative 6x is minus 48x. 8 times negative 27 is negative 216 equals 9. I'm going to combine these two like terms. 3x minus 48x is going to give me negative 45x. If I add 216 to both sides, then I end up with negative 45x equals 225. Divide by negative 45. X equals 225 divided by 45, or negative 45, is negative 5. So I've got negative 5 for my x value, and I still need my y value. So I'm going to plug this negative 5 into this equation. I can plug it into any equation I want. It's just a little bit easier for this one because I already have y equals this mess. So y equals negative 6 times negative 5 minus 27. Negative 5 and negative 6 is 30. 30 minus 27 is 3. Oops. Positive 3. So y equals positive 3. Put that right there. Bop, and I'm done. And that is substitution, solving by substitution. Now, let's go ahead and solve by elimination. Now, if you see this on a test and it says solve by substitution or solve by elimination, I don't really care which one you use. Use which one you feel more comfortable with. Because on the test, it's not going. It doesn't matter. You just do the work the best you can, the way you know how, and get the right answer. All right, example. 5x plus 3y equals negative 17. I mean, it's negative 19, sorry. And 8x plus 3y equals negative 25. Okay, so now elimination, we're going to use adding and subtracting here. And we look to see what coefficients, the number next to the variable, can we eliminate, and so, or what terms we can eliminate. So 3y and 3y, those are almost the same, right? If one is negative, well, 3y and 3y are the same. We want them to be opposite. We want one to be positive and one to be negative. So let's multiply this whole thing by -1. And so we end up with 5x plus 3y equals negative 19 over negative 8x minus 3y equals positive 25. We've just multiplied both sides by -1. And now we just add down, we just go add straight down vertically. 5x and 8x, or negative 8x is negative 3x. 3y and negative 3y are 0 equals negative 19 and 5 is 6. So I've got negative 3x equals 6, divide both sides by negative 3, and x equals negative 2. So I've got negative 2. Remember, I also need my y value. So I'm going to take negative 2 and I'm going to plug it into any of these equations up here. I'm going to plug it into this one. So 5 times negative 2 plus 3y equals negative 19. 5 times negative 2 is negative 10, plus 3y equals negative 19. Add 10 to each side. 3y equals negative 9. Divide by 3. Y equals negative 3. Negative 2, negative 3 is the point at which these two lines intersect. Let's do we try. So this is one that we would do together in class, but we're going to do it this way. Equals 13. So 2x plus 3y equals 13. 4x minus 2y equals 18. Now this time we've got to make a different kind of decision than we did last time. This time I'm going to look at I'm going to need to multiply one of these equations or both of them by some number in order to make it so I can eliminate something. For this one, I'm going to look at this one on the top and see how this is 2x and the one on the bottom is 4x. So if I multiply the whole top by negative 2, then this will make that negative 4x, and then I can eliminate the 4x. So that's how I'm going to work this out. And so I'm going to rewrite this with having multiplied both sides by negative 2. Make sure that negative 2 gets to every single term. Negative 4x minus 6y equals negative 26. It's very easy to forget to multiply all of the terms. 4x minus 2y equals 18 is the equation on the bottom there. The 4x's go away. Negative 6y, negative 2y, negative 8y equals negative 26 and 18. That's going to give me a negative 8. So I divide both sides by negative 8. Y equals positive 1. And I'm not done. I need my x value still. So I'm going to write over here 1 for my y value, and now I need to find my x value. I just plug this, y equals 1, into one of these equations. I'm going to plug it into the top one. 2x plus 3 times 1, that's my y value, equals 13. 2x plus 3 equals 13. Subtract 3. 2x equals 10. Divide by 2, both sides. X equals 5. And now I'm finished with that one. All right, let's give you guys one to do on your own. How about one that is almost exactly the same as the one we just did? Why not? 4x minus 3y. Oh, this one is even easier. Equals negative 22. 2x plus 3y equals 16. I'm going to give you another one to do here as well. 5x plus 3y equals 52. And 15x plus 9y equals 54. Okay, do this one, and then do this one. All right, so go ahead and do this one. Pause and do the work. Okay, so now for this one, I am going to multiply the bottom by negative 2. Now, sometimes you might be in a situation, oh, I'm not going to multiply this by negative 2 at all. Forget that. No way. But you might sometimes be in a situation where you need to multiply the top one by something and the bottom one by something. So just be aware of that, that might happen. For this one, I've got negative 3y and positive 3y. I don't need to multiply by anything. These guys cancel out to be 0. And then I've got 4x plus 2x, which is 6x. I'm just going to write that right here. 6x equals negative 22 and positive 16 is negative 6. Divide by 6. X equals negative 1. So I'm going to put my point right here. Negative 1. And now if I plug negative 1 back in here, I got I got 2 times negative 1 plus 3y equals 16. This is negative 2. So if I add 2 to both sides, I have 3y equals 18. Divide by 3, y equals 6. So my answer is 1, 6. Now, if you haven't tried this, you try over here. Go ahead and do it. Go ahead and pause and do it now. All right, let's take a look at this one. So for this one, I want to multiply the top by negative 3 so that I can get this 15 out of here. Negative 3. So when I do that, I end up with negative 15x minus 9y equals 52 times negative 3 is a negative 156. And then I've got 15x plus 9y equals 54. Uh-oh, I feel like something weird is going to happen here in just a second. Negative 15x and positive 15x is 0. Negative 9y and positive 9y is also 0. 0 equals negative 102? No, it does not. If you end up with this, then you know you've got no solution. You've got no solution because the two lines are parallel to one another. Now, if you ended up at the bottom here like this, and you had like one number equals another number, then you would have a situation where both of the lines were on top of each other like that, so it would be an infinite solution in that kind of situation. But that is not the situation that we have here. This is parallel. 0 equals negative 102. You have no solution. Now, here's the last bit that we're going to do for this section. Characteristics of linear systems. Here's where we're going to talk about this kind of stuff happening as well as this. So we've got 3 different characteristics that we're going to talk about. One is consistent and independent. One is consistent and dependent. And the last is inconsistent.